So just as a recap, we always read as if X is on the left, and we ask ourselves, how would we pronounce that? So this is the symbol for less than if you're reading from left to right. This is a symbol for greater than, less or equal to, and then greater or equal to. So that little line that's underneath, that symbolizes the or equal to part of that phrase. Now, what I do want to do is make sure that we understand that these are what we call inclusive phrases. And that's a term that I would like to hear from you this year. So inclusive means that if I have, let's say, X is less or equal to 3, this is the same thing as saying, give me numbers that are less or equal to 3. So obviously 0, -1, -2, 2.9, all of those are clearly less than 3. But you can also use 3 itself as an answer to my question, because 3 is less than or equal to itself. Now, if I write X is less than 3, then you can't say 3 as an answer to that. So the reason we say this is an inclusive phrase is because 3 can be included as an answer. So the answer includes the endpoint. And for these guys right here, it means no. You could say 2.999999999, repeating, but you cannot say 3. So that's the difference between those. Now, these are some alternative phrases that also mean those symbols, so that's something I would like you to have down. If you see these phrases, which come up quite commonly in our reading, I want you to be thinking of these symbols. Specifically, the word exceeds. So you can see that on some legal rules. For example, if you exceed the speed limit, you can get pulled over and get a ticket, right? If you decide after you're all grown up and on your own and you're over 21, you want to go out and have some wings and drinks with friends, for example, your blood alcohol content cannot exceed the legal limit. All right, so that's a word that we want to know. And then we have the phrases at most, maximum, and at least and minimum. So I know that's a little misleading. Most actually means less, and least actually means more. And really, all you should have to do is say it in a sentence to yourself. And here's my classic example. When you go to an amusement park, like take Hershey Park, for example, you can't put like a baby on a roller coaster, right? Because they're not the proper height. So you have height restrictions. So a lot of times they'll have posted in front of the ride, you have to be at least this tall to ride, which means you have to be this or higher if you want to ride the ride safely. All right, it's the exact same thing with minimum and maximum. So minimum actually means you have to be more than this, and max means you have to be under or equal to this. So all of these are inclusive phrases, but you want to make sure that you try to get the signs correct with those phrases. So we're just going to do a little quick review of graphing. So the first thing I always say is, when you see these inequality symbols, you want to imagine that there's an arrow being formed by that symbol. So if you were to put this as an arrow, it looks like it points to the right. So what you would do is put 4 on your number line. We're going to draw an open circle. That open circle represents the statement that 4 cannot count as an answer. So I want numbers strictly more than 4. 4.00001 would be okay, but not 4 itself. And that's why we need that open circle. And then the arrow would point towards the right. So any number to the right of 4 could be substituted in for X, and you'll get a true statement. It's the same thing here. So again, we're not allowed to use 4 as a solution, which is why we use an open circle. And then we want to go to the left. Now for these ones, we are allowed to include 4. It says right here, we can pick numbers less or equal to 4 to plug in for X. So we will use a solid circle to represent that 4 could be used. And then anything to the left of 4 could also be used. And again, this, except my arrow would go towards the right. So most kids actually are pretty good at remembering how those graphs work. I purposely, for this section, put all the letters on the right side instead of the left side, because I am forever having kids do this. Because they're like, well, the arrow goes to the right, so mine does too. But this is written backwards. X is on the wrong side. So a lot of times kids will overlook that fact. So what I recommend to you is always rewrite your inequality. It's a little trick I call the swap flip trick. I like to swap places with x and 6, and then I'm just going to flip my sign around. And that's what I want to graph. All right, so I should definitely have an open circle, but my arrow actually does go left. So you're either going to do the swap flip trick and then go, copy your arrow the way theirs is facing, or you're going to read the problem backwards, which a lot of kids mess that up. So I probably would just recommend doing the swap flip trick for all of these. So that's what we're going to do. We're going to swap places with the P and the 5, and then the X and the 2. And then we just flip that sign around. So these are my new problems. This is what I want to graph. All right, so we're going to have a 4. Because it's not inclusive, we want an open circle and going to the right. We have 5. We want a closed circle going to the left. And here we have a 2. We want a closed circle going to the right. Now our last little recap here is how to solve. You would treat this just as if it said equals. So we would subtract 6 on both sides, and we get 4. Now you just don't write x equals 4, you got to use the inequality symbol that was in the problem. Right. So that's one thing to do, is to know how to solve it. The other thing is to understand what your answer stands for. So your goal is to figure out, what could I have plugged in for x to make this statement true? So numbers plus 6, when you do that, you want to get something less than 10. You're trying to figure out what numbers would work for x. And what this means is you could pick anything that's below 4 and it'll work. You can plug in 0 for x. 0 plus 6 is less than 10. You can plug -1 in for x. You would get 5. That's less than 10. So if you were to sit here and list all the numbers that are less than 4, like 3, what about 3.99, for example? -1, -100. There's an infinite amount of numbers that could work for x. So there's no way you'll be able to sit here and write them all out, and that's why you have to use an inequality to represent that. Okay, so this is just saying, Mrs. Stoltz, anything that's smaller than 4 will work. There's all my answers. All right, so number 10, we're going to have to get our x's on the same side. So I prefer adding 2x, which means I would have to subtract 3. So 6 and 2, of course, make 8. 5 minus 3 is 2. And you want to be very careful here. A lot of kids will tell me the answer is 4. The answer is not 4 because you divide by whatever's in front of x, the coefficient of x. So it's totally fine to leave that answer as a fraction. I just make sure, I want you to reduce it. So it should be 1/4. So anything that is smaller or equal to 1/4 can go in for x, and you'll get a true statement. All right, next one, we're going to distribute and get 4x minus 8. I don't recommend you move the 5x over here or undo the 5x, because you'll have nothing else over here to work with. Could mess you up. So instead, we're going to minus the 4x over. And 5 minus 4 is just 1, and you don't have to write the 1. And there's your answer. You're totally fine to circle this right now as is, and it absolutely is correct, but it is a good habit if you just do that little swap flip trick real quick. Just in case you would have to graph it, then your chance of error goes down. Now the bottom ones are going to be a little trickier, so the first thing you want to realize is there is a 1 in front of this x, so we would divide both sides by -1. Now when I do that, I will get -5. But if you recall from Algebra 1, if you divide or multiply by a negative number, so for example, I divided by -1, I have to flip my sign when I go to write my next line. So again, if we multiply or divide by a negative number, then we have to flip the sign. That's going to happen in number 13. So if we start by dividing by -1 on both sides, I'll get -7. I'll have an x, but I have to flip my sign because I divided by a negative. Again, I can circle this and that's fine, but it's a good habit to have the letter on the left side. So we do a little swap flip trick. So that gets a little confusing because you actually had to flip the sign twice. You had to flip it once for the negative and the other time because it was on the wrong side. All right, last but not least, when you're dividing by -5, you can undo that by multiplying by -5. So I'm going to do that first. I always want you to cross out your top and your bottom -5 because you can divide those into each other and make 1. So you're left with just an x, a -15, and because you multiplied by a -5, you have to flip your sign in your answer. All right. So next time in our lesson video, we'll be doing compound inequalities, which is even more work than what we did today.